We have another topic for double angle formulas, and we are asked to find tangent 2 theta in exact form from the given data. And for number 1, we have tangent theta given as 3/4. And if we represent that by triangle, we have here 3 by 4 by 5. And then the formula for the tangent 2 theta is equal to 2 tangent theta. So this one is equal to 2 tangent theta over 1 minus tangent squared theta, no? Is equal to 2. We substitute the value of tangent theta, which is 3/4. So 2 times 3/4 over 1 minus 3/4 squared, no? 180 squared. So this one here, 2 cancels out and this one becomes 2. So the numerator becomes 3 over 2 over 1 minus the square of 3/4 is 9 over 16. So this one becomes 3 over 2 and 16 minus 9 over 16. So we have here 3 over 2 times 16 over 7. 2 and 16 cancels out. 3 times 8 is 24 over 7. So the final answer is 3 and 3 over 7. So for number 2, the given is tangent theta. No? This one is tangent theta. So this one is tangent theta. So, excuse me, no? So this one is tangent theta is equal to negative 5 over 12. No? So tangent 2 theta is equal to 2 tangent theta 1 minus over 1 minus tangent squared theta. The given is 5 over negative 12. So 2 times 5 over negative 12 over 1 minus, substitute the value of theta, which is 5 over 12 quantity squared. So squaring this one, we have here the numerator will be negative 5 over 6 over 1 minus the square of that is 25 over 144. So to continue, that is equal to negative 5 over 6 over 144 minus 25 over 144. So to multiply it by the multiplicative inverse of the numerator of the denominator, that will become negative 5 over 6 times 144 over 119. So this one becomes 24 times negative 5 is negative 120 over 119. So this is our final answer. So for number 3, we have here tangent theta is equal to square root of 5. If this is square root of 5 tangent, so this one, our base is equal to 1 and our hypotenuse is equal to 6. Because it's square root of 5 squared, negative 5, square root of 5 squared is equal to 5 plus 1, squared is equal to 1, 5 plus 1 is 6. Tangent 2 theta is equal to, the formula will be 2 tangent theta 1 minus over 1 minus tangent squared theta. Just substitute the value of square root of 5 for the tangent theta. So it becomes 2 times square root of 5 over 1 minus square root of 5 quantity squared is equal to 2 times square root of 5 1 minus 5. So this one is 2 square root of 5 over negative 4. So the final answer will be negative square root of 5 over 2. For our proving, verifying direction or exercise double angle formulas is for sine 2 theta is equal to 2 sine theta cosine theta. For cosine 2 theta, that is equal to cosine squared theta minus sine squared theta. And we have to prove the identity by using the double angle formulas, which tangent x will be to be 1 minus cosine 2x over sine 2x. So we work on the right side because it's more complex than the left side. No? and it contains the simplified form for cosine, no? And sine. Working on the right side, for this side, this cosine 2 theta is equal to, so 1 minus cosine 2 theta is cosine squared x minus sine squared x over this one is 2 sine x cosine x. So we simplify the numerator, we get rid of the parentheses, this one becomes 1 minus cosine squared x, and this one positive becomes positive sine squared x. So to simplify further, this one is 2 sine x cosine x, so just copy. So this one, 1 minus cosine squared x is equal to sine squared x. And then you just copy sine squared x, and also copy the denominator to be 2 sine x cosine x. Sine squared x plus sine squared x is equal to 2 sine x, 2 sine squared x over 2 sine x cosine x. We cancel out 2, and we cancel out 1 of the sine x, and this one sine x. No? What remains is sine x over cosine x, which is equal to tangent x. So we successfully prove that tangent x is equal to 1 minus cosine 2x over sine 2x. So we will have some more problems, exercises on the Hammond angle formulas and some other product and some formulas. So thank you for watching our videos for today, and please don't forget to subscribe to my YouTube channel by Predaton, and if ever you have some problems, comments and suggestions, please send it to us, and we can use it to improve our presentation. So thank you, and see you again later.